A typical first step in analyzing your data is getting to know your data in the first place. For the NumPy arrays from before, this is pretty easy because there isn't a lot of data. However, as a data scientist, you'll be crunching thousands, if not millions or billions of numbers. Imagine you conduct a citywide survey where you ask 5,000 adults about their height and weight. You end up with something like this, a 2D array which I named NP City that has 5,000 rows corresponding to the 5,000 people and 2 columns corresponding to the height and the weight. Simply staring at these numbers like a zombie won't give you any insights. And zombies can't even interpret numbers correctly anyway. What you can do though is generate summary statistics about your data. Aside from an efficient data structure for number crunching, it happens that NumPy is also good at doing these kinds of things. For starters, you can try to find out the average height of these 5,000 people with NumPy's mean function. Because it's a function from the NumPy package, don't forget to start with np dot. Of course, I first had to do a subsetting operation to get the height column from the 2D array. It appears that, on average, people are 1.75 meters tall. What about the median height? This is the height of the middle person if you sort all people from small to tall. Instead of writing complicated Python code to figure this out, you can simply use NumPy's median function. You can do similar things for the weight column in NP City. Often, these summary statistics will provide you with a sanity check of your data. If you end up with an average weight of 2,000 kilograms, your measurements are probably incorrect. Apart from mean and median, there are also other functions like core-coef to check if, for example, height and weight are correlated, and STD for standard deviation. NumPy also features more basic functions such as sum and sort, which also exist in the basic Python distribution. However, the big difference here is speed. Because NumPy enforces a single data type in an array, it can drastically speed up the calculations. Just a side note here. If you're wondering how we came up with the data in this video, we simulated it with NumPy functions. We sampled 2 random distributions 5,000 times to create the height and weight arrays, and then used column stack to paste them together as 2 columns. Another awesome thing that NumPy can do, and that you'll learn to do in the next course. Another great tool to get some sense of your data is to visualize it, but that's something for the next course also. First, head over to the exercises to learn how to explore your NumPy arrays. And so many congrats on making it this far. You've come such a long way.